Thanks everyone for joining our mini conference today. We're actually moving towards the end of the conference. So this is week 2, and today is Thursday, so we have just 2 talks left. So today and tomorrow. So on Monday, Jan was talking us about setting up a project, AI project for success. Then Ben Wilson was talking about running away from complexity. How can we make simple projects? Yesterday with Lina, we discussed managing stakeholders. Today, Duke will talk about search relevance projects and how and why they will fail. Probably not only about that, but also how to avoid that. And tomorrow we will have our last talk about the importance of data quality. I would like to thank all our friends from other communities who helped us with spreading the word about this conference. Thanks a lot. And there is a link in the description to the conference page when you can scroll down and see all the partners, and you can check what they do. Please do this. If you're watching this from YouTube, please subscribe to our channel to get up to date with all our videos that we have, and join our Slack to talk about data. Finally, during today's talk, you can ask any question you want. So for those who are watching on YouTube, go to live channel and there is a pinned link. And for those who are watching on LinkedIn, I'll post a link shortly. And then finally, I would like to congratulate all the winners of Duke's book. So we had a giveaway. People could go on Twitter and retweet. I would like to congratulate the 5 winners of the book. I will contact you after the talk today. And this is my last slide. And now, Duke, the floor is yours.
Cool. Thank you. Thank you. So welcome, everybody. Let me share my screen, make sure this works.
Does?
Great. Present. Can everyone see?
Yes.
Awesome. Great. So hi, everyone. I am Doug. I work at Shopify, and Shopify is the leading, our mission is to make commerce better for everyone. We have a slide with lots of stats. But to me, the important thing about Shopify is working in the search and discovery space is we want to give the tools that a lot of the major e-commerce companies invest heavily in. We want to try to build those into our platform so that they're not just the purview of the giant e-commerce companies out there, that we can make commerce better for everyone. And that's Shopify's mission. And discovery is like walking into a store and trying to find something interesting, or you know what you're looking for and you're going to go straight to that aisle and get it. So discovery is a huge part of that picture. And that's what me and my team work on. So we're really just getting started in this space. So if you're interested in this talk, you want to help me and the team on the mission, please feel free to reach me. I'm in the Data Talks community. So like I said, my name is Doug. I wrote books. I'm helping out with AI-powered search. I've got a couple of chapters in that. I created the Elasticsearch Learning to Rank plugin or co-created it with Wikipedia Search and another company called Snagajob. And I created a suite of relevance tools called Cupid, and there's another tool called Splainer that's now maintained by my former company, Open Source Connections. So all of this is through years of work doing search relevance. So I've done search relevance since the early 2010s at Open Source Connections, and I worked there for 8 years, and I did all kinds of consulting, and they continue to do great consulting for lots of different major organizations in the search and discovery space. And now, of course, like I said, I work at Shopify. And all of those years, I've seen plenty of failures, and I've participated in plenty of failures. So I tell the client to try out this amazing search experience, and they wonder why searching for water bottles returns milk, and I run away. But really, I want to come back and tell you, don't do what I did. or let me teach you what I've learned in my journey through all of these different clients, projects, and things where I've had my fair share of successes, but I've also seen my fair share of failures. So I want to walk through how to fail at search relevance. And I think I could probably make this a day-long talk, but really I'm going to focus in on one specific aspect, which is around really measurement and instrumentation of relevance, which is kind of foundational. So how do we know when something is relevant or not? And then if we have that data, then we can go and implement all kinds of crazy algorithms to solve this problem. We can go and, anything is possible. The world is our oyster. Once you have good training data, there's a huge library of crazy stuff you can do, right? So, but when you're doing ML in production, in this case, search relevance, you really care about the operational concerns of where training data comes from, how much of it you have, how you interpret it. And it's funny how much time we spend cleaning and preparing data just to get to that one line of scikit-learn code that says something.train or .fit, and we are done, right? And we thought that last line was the fun part or the hard part, but really it's like the 99% of the stuff that goes into it. So we're going to talk a little bit about that primarily. The first thing, just to set the stage for that, is the first thing we want to do if we want to screw up search relevance is just avoid failure at all costs. And what can happen, of course, is we have these stakeholders, maybe this angry, important person who yells at us and tells us that search is terrible, please fix it. But when we go to look at the search, it kind of looks terrifying. It's scary. So search is a problem where often there's all these production systems that are in place. There's usually a side that an indexing pipeline. Indexing is just the process of loading a search system with data. A search system has an index primarily where it returns data. And then of course the querying side. How do we query the data? What's the systems that get a query from the user, maybe interpret it and return results? The search system itself, at Shopify, we use Elasticsearch. And this is actually a huge area of investment that we've spent at Shopify, is getting this sort of feedback loop, the operational side of this feedback loop better. Because what happens if it takes weeks to index? You're just not going to try any new indexing strategies. And you're just going to give up improving your search relevance. And then you're just not going to do anything. So operationally making it so that an index takes 15 minutes, it is just a no-brainer, opens the world up of the different kinds of relevance things you can experiment with. And of course, the same thing goes on the query side. If there's no way to really reliably deploy experiments or try out new ideas, then you're not going to do anything if the ops aren't there. So we've had this journey at Shopify, and I put a link down here on the bottom left. We've been working and are continuing to work on our indexing pipeline. As a lot of people may know, Shopify is a huge Rails contributor. And as part of that, we have a large monolith, and our indexing was pretty heavily tied to that monolith. You can read a little bit more about the story of how we extracted some of our pipeline, put it into Apache Beam, which uses Google Dataflow, a streaming system, away from that. And we've gone from sort of weeks to reindex to now hours over all of Shopify's product data, which is billions of products. So that's something we've actually spent a lot of time improving. So even when we have that in place, so when I joined Shopify, like I said, that indexing pipeline was in place, but the next question was, okay, how do we make this better? What about I have this thing, I can deploy new indexing changes, I can change the structure of my index, I can change the query side, I can reconfigure the search system. That's great. But even then, change is terrifying because I've worked in environments where people are just like, well, I know I can change search and make one query better and manually try it out. What about thousands of others? How do we measure that? So that becomes more of a data problem. And it's a problem where one of the first things organizations do, and so they might get one of these product managers or people to go and start to manually label results as relevant or not for a given query. And I have one of the projects, my earliest projects I got started with in search relevance, which was the foundation for Cupid. I basically did this. I was literally sitting next to someone coding Cupid to build it, while John Berryman, my co-author of Relevant Search, coincidentally, was trying to improve search relevance. And I said, this is crazy. We need like a test setup. So we were building a tool that let someone actually go and label results while John was tuning. And then, I was like hacking on a Flask app on a laptop to the side so we could urgently solve these relevance issues. And we actually got someone to label results, and that became sort of a basis for improvement. So this is called in search, this is often called a judgment list or just judgments, where we have a quote unquote grade. You can think about this as, grades in school, A, B, C, D, so on. Usually they're on different scales. They might be 1 to 4, 0 to 4, 1 to 10. In this case, I'm showing a 0 to 2, where you have 0 irrelevant, 1 kind of meh, and 2 relevant. So that's often the starting point for search teams. So now, of course, if we have our ops figured out, we can index quickly, we can query quickly, we have a sandbox to experiment with. Now I can throw 1,000 queries at the search system, check that against my test data. There are statistics. You may have heard of some of these statistics, but one is called a discounted cumulative gain, which is a ranking statistic to see if good stuff is moving towards the top. And you can start to see, oh, I'm actually making progress. So instead of being terrified of changing the system that serves millions of queries, now you can gain confidence in your changes. You can feel good about the direction. So gaining this kind of confidence is pretty revolutionary to search teams. It's pretty foundational to a lot of the confidence that search teams have. But unfortunately, this can happen. So this is sort of the first, you gain this confidence, and then what happens? You launch the A/B test, and it doesn't work out. And if you go to a lot of, one of my favorite conferences, Haystack, there are a lot of conference talks where people talk about using machine learning to improve search. And this is the common theme, is getting the judgments, the training data right, is a constant iterative process. And then eventually you figure something out, you get the A/B test out, and it actually improves it. And then you figure out, oh, this is the algorithm or whatever system I need to get good judgment data. Therefore, I feel good about it, and I can see that it's showing in my A/B test when I improve against that training data, things get better against my like KPIs or whatever. And of course, how did we screw up? This perhaps is what happened. This is we had this one person, thoughtful person perhaps, and maybe their feedback was not a true reflection of users. Maybe they have their own biases and perceptions, their own things they like. And maybe instead we should rely on clickstream data. So clickstream data starts to come into the picture. We can get lots of it. We can get it from real users, and we can start to interpret that. That seems pretty ideal. So the next thing we might do to fail in search relevance is just drive our training data 100% on click-through rate. So click-through rate is, how many times somebody clicks on something over how many impressions or maybe page views it has. So just stepping back to look at this problem again, when we look at like this person on the right who labeled results, maybe they're the pessimist, they never like anything, they have their favorite, maybe they're skewed opinions or whatever. And then we have this other, maybe a product manager or whatever, who thinks everything is great all the time. And they just have different perspectives. This is one search in Shopify, by the way, that you can find in an app called the Shop app. That is something our team helps out with. This search is for, you can search in there now for specific, it's kind of hidden, but you can go and search for specific Shopify merchants. And this is one of the things that I'm going to use this as an example for the rest of the talk, because this was a good testing ground for us for experimenting with different search strategies. So we have two different points of view on this fashion query. Here we have a fashion query, and we return these 3 fashion merchants. And one person doesn't see their favorite fashion store, and the other person thinks, oh, this is great. How in the world can they optimize relevance? So how could we learn what's relevant for fashion? Whoops. The obvious thing is to start looking at clicks. Which of these is getting clicked on more? And we might notice that certain things get clicked on more. It seems like the top result gets clicked on more. And we can use this to generate what we refer to as implicit judgments. So just like in recommendation systems, people talk about explicit versus implicit ratings. So explicit ratings are when in a recommendation system, like you have gone and in say Pandora or Spotify or on Netflix, you've actually rated something. You've said, this is 5 stars, this is 1 star, and then it will generate recommendations based on that. And an implicit is based on how users actually interact with the discovery interface. And people might implicitly do things that they're not even conscious of. They might not want to admit. Maybe there are all kinds of like little subtle subconscious things that people do that we might actually capture from their behavior. And that's what we're trying to do here. We're trying to build judgments based on implicit behavior. And maybe we have our optimist product manager here who is interpreting this click-through data as a positive thing. If we see the top thing is clicked on more and the second thing is clicked on slightly less and so on, it seems like we're doing well. Well, it turns out it's not quite that simple. There is a lot of research showing that for whatever reason, there are known position biases in search result click behaviors. So when you see a search result, you tend to scan from top to bottom. And there's a lot of research on this, and it's not entirely consistent. Like there's various behaviors that happen. Some people actually scan from bottom to top. People sometimes jump around, but on average, most people will scan from top to bottom. And this is called position bias. You've probably had a case, for example, where someone has said, just click on this button. Like just now when I was supposed to present, I was like trying to find the present button. Someone says, go click this thing in some random UX. That happens on search too. Like people just don't notice things even when they're right on the screen. So, so we have to adjust for this bias when we think about click-through rate. And it's going to be more pronounced, obviously, on a desktop interface where there's just a lot more visual real estate to get lost in. But it's even here, and you can see it. This is actually data that I calculated months ago using this shop search interface showing the click-through rate of each rank. So you can see a 0.104 for the first rank. So this 0.09 is actually below average, 0.08, 0.07. So all of these are actually kind of below average for what these ranks would be getting. So they actually aren't, it's not doing so great. So what do we do? So there is a set of algorithms from the search industry called a click model. So a click model is a way of turning a click stream into relevance labels. It generally uses clicks primarily. There are things that use hovers. There are things that might try to incorporate post-click behavior, but clicks are usually the most plentiful signal that we get. And as we'll see, like confidence in our data is important. So a click model tries to account for position bias. That's its primary job. It might incorporate other biases. Some click models are specific to certain use cases, like autocomplete or trying to think about a grid set of search results or different search interfaces. But others try to be more general purpose. I'll talk about kind of a general purpose one that we use at Shopify. And they compute a relevance probability. So it's a probability that something is relevant. And this is something we can use as an implicit judgment from 0 to 1, kind of as a floating point number. So as an example, I'm going to walk through this one. It's called, it sounds really fancy, and it sounds like a name that you can use at like parties to impress your friends, assuming you might be able to have parties right now. It's called the Simplified Dynamic Bayesian Network. And underneath the hood, if you look at how this is derived, there is a complicated Bayesian network algorithm. But at the end of the day, they build this Bayesian network algorithm. They say, well, if you use this really simpler version, it's 90% as accurate, and it's way easier to implement. So that's what most people that I've seen actually do. And how this works is you basically assume that nobody examines past the last click in a session. So you can see here this lightning bolt, that's a click. We track what was examined. So these two were examined. We track what was clicked, and we track whether something was the last click. Anything that was clicked is considered attractive. So it was good, nice enough to be clicked. It looked interesting. And of course, people accidentally click things, but on average, this pattern will hold. Anything that was skipped over will be considered less attractive. For some reason, they didn't click it. And then there is an assumption, we don't actually use this right now in our data at Shopify, but there's an assumption that the thing that was last clicked is the thing that was satisfying to the user. So we could take this over another session. We have two things that are clicked. You can see this was the last clicked. We assume everything was examined, all three, and we have two that were clicked. And of course, these results can shuffle around over time as relevance algorithms change and things. So we have to track these per session to know what was the listing at that time, what got clicked, what didn't, and so on. So that's another operational challenge, is just having the instrumentation to gather this. If we sum these across all of the sessions, in this case, the two that we've seen, we can see the total number of examines, the total number of clicks, the clicks divided by examines, and that's what we use as our relevance grade. We use the attractiveness because that comes in the largest amount of bulk. You can think of this as a position biased adjusted click-through rate, where you notice here, we just assume this bottom one just wasn't as examined as much. So we don't necessarily punish it as harshly, even though it was shown on this listing. So this can be used as a relevance judgment. And at Shopify, that's really what we started to do. We started to use this. So we'll put it all together. And this is some rows of this fashion query with some, for each row here is a different merchant. And you can see here, we have all kinds of different relevance grades. And this is sorted by what we seem to be assuming is most relevant to least relevant based on our click data. And we're done, right? how could this data screw this up? Well, it turns out life is even more complicated, because when you look at this data, you see a broad variety of stuff. You notice some things that have tons of observations and some things that have very few. And if you notice here, we have this row here, we have 6 clicks out of 8 examines, and we give it a grade of 0.75. Is that really more valuable than this thing here that has a ton of traffic? So the next thing that we can really screw up is just ignoring how confident we are in the data. Because if we were actually to train or to manually tune relevance or whatever with this data as our baseline, we would prefer things that got 1 click versus 1 examine over this row here that has a tremendous amount of data. We have tremendous amount of confidence in its 0.73, and we have very little confidence in this 0.75, or some, maybe, are we really sure this 0 out of 3 is super irrelevant? And we basically need to figure out a way to give some more, we need to figure out a way to deal with this confidence problem. Now, one way to do it is just to filter out, and people do this all the time. They say, well, I have some threshold and I cut out this, in this case, anything below 10 examines. So we know, okay, it was only seen by users 10 or fewer times, we're not going to look at it. Unfortunately, what that leaves us with is a lot fewer training examples, because this is going to follow a power law distribution. We're going to have like this one hot spot fashion merchant, lots of stuff on kind of a torso of a power law distribution, and then tons of stuff down the tail. So we're going to eliminate, we might eliminate the majority of our observations. And the other question is, when we eliminate them and we eliminate a lot of our data, how do we treat things when we just decided to ignore their data about relevance, and how do we treat things we have 0 data on their relevance? So another option is, can we capture the confidence somehow in the grades value, in the output grade? Is there some system or method that we could go through to capture the confidence in this adjusted value? Keep the 0.73 on the really reliable one, but maybe not put as much value in this lower confidence row. How do we do that? Well, one way to do it, and this is what we do, is to use the beta distribution. And I want to thank Renee Kriegler for turning me onto this. He pointed this out, and I think this is something that is really valuable for these kinds of problems, where we can establish with the beta distribution not just this idea of, well, the beta distribution is basically a probability distribution over probabilities. And that might blow your mind, but on this x-axis, this is the relevance grade. Remember, this is our probability of relevance. And we're not really sure if we're really certain on that, or if it's like, oh, this distribution should be really wide and we should be really uncertain about it. And what we can do, because we are going to have all of these documents will have very little data and some will have higher confidence in, we can encode our current relevance grade as 2 values, A and B. And these values, A and B, or alpha and beta in the traditional definition, and that's where the beta distribution name comes from, we can encode in them the confidence we have in our data. And how the beta distribution works is there is an expected value, and the expected value is A over A plus B. And of course, there are many ways, many A's and B's where we can get this, like, let's say our default relevance grade, if we have no information, is we're going to say is 0.111. There are many ways we could define A's and B's that give us that value. But what happens is if we create an extremely high A and B, it creates an extremely confident distribution. So it makes it really narrow. You could see the difference between this. So if we start with what we call a prior, like a default assumption of the relevance of a document with no information, and we use a beta distribution to describe that prior. So we basically find an A and B that we're happy with. Then we could start to adjust A and B as we get more data. And if our prior is weak, so A and B start at 1 and 8 and have a 0.11, and we adjust A up a little bit, that's going to really push our grade a lot higher. Because you could see A 2 over 2 plus 8 is 0.2. But if we have a really strong prior, this really tight one, it's going to be really hard to budget. So we have to like, really get a lot in this A value. So what does this have to do with clicks and everything? So what you can do is you can say, okay, I'm going to establish a prior relevance grade. And in this case, I think, we have, for some reason, my table changed to 9. Pretend these are 8s. But let's say we have a prior A and B that we've selected. We have an intuition for how relevance should work by default, that maybe we don't want to completely say they're 0. We would say they're slightly above 0 because we're not entirely sure. But a random thing from the corpus is probably irrelevant. Maybe that's our intuition. And we want to, as we get more click data, we can adjust A and B accordingly. So in this case, we start with a relatively weak prior, and we compute a posterior. So we say, okay, A is the prior A plus the clicks. So in this case, we have 0 clicks, so the posterior doesn't change. But B is any examine without a click. So it's anything that happened without a click. So you can see here that on this one, clicks, we add that to A, and then we get a posterior A. And same thing with B. We have, in this one, we don't change B because all of our examines also have clicks. So we have a posterior beta distribution that we use. And as we get more data, these numbers are going to go higher and our certainty is going to increase. So if we look at at these examples, the posterior grade here, you can see here that, okay, here's the actual grade computed from these new A's and B's. So that's them being adjusted around. Remember, we started at like 0.11. This top one got adjusted down a little. This one and these two got adjusted up a little. And if we apply that to our larger data set, back to our data that from our shop search, you could see here that this one here, 345 plus where we have we start with A of 1, B of 8, and we usually start at Shopify, we used a relatively weak prior like this. You can see that this weak observation, it's not really overcoming the prior very much. It's staying pinned closer to that prior. But this much stronger observation is almost approaching the natural sort of clicks over examines. It's approaching this 0.73. And in any future data, this one is going to change a lot faster, whereas this one's going to change a lot slower because we have just so much more data and the certainty is much higher. So we trust this observation a lot more. So now when we go and we change our relevance, or we tune our relevance algorithm, we are going to prefer these observations that have much more data over these ones that have a lot fewer data. And we're still going to have a rich data set, It's just that each data point is going to have a different amount of uncertainty. And even more important, like maybe even more importantly in some cases, when we get an observation we have absolutely no data on, we could make a default assumption based on our prior that it's maybe a 0.11 grade with a pretty wide uncertainty and beta distribution. Now, what I haven't messed with, which would be interesting, is to take the uncertainty and use it with the grade in the ranking evaluation. Right now, we just take this output, but it would be interesting to say, okay, it's a 0.411, but with a huge standard deviation versus this with a low standard deviation. That would also make things kind of interesting to see what kind of uncertainty you get. So those are two really important problems. And the next thing that can happen is you may be thinking, okay, if all users ever see is these three results, let's say our algorithm doesn't change or doesn't change very quickly, what you can imagine, there's probably thousands of fashion shops in Shopify's network. How many of them are getting sort of in the mix and clicked on and that kind of thing? How reliable is what we're learning? Because if users never get out of this bubble of search results, there would be so many things that we just never get clicked on. And you can actually get situations where you get kind of a negative feedback loop where you think search is okay because there's these three things that are getting clicked, but you never actually see the thing that could get way more clicks. And so you get what's called presentation bias. Presentation bias is being biased. All your click data is biased towards what's being shown to users. And that's something that has to be actively overcome in search teams. And it's a very hard thing to do. I'm going to present one thing. We haven't really gotten too deep into this at Shopify, but it's one thing that I see in the past, and it's something I write about in AI-powered search as a potential solution to this. So one way to think about this problem is in an explore versus exploit fashion. So exploit is when we take the data that we know about and we have high confidence in, and we use maybe our algorithm that's heavily tuned towards that data, and we show users that, sort of known algorithm that works well. Explore, on the other hand, is when we strategically try something out. So you might go to a restaurant. We were talking about favorite food earlier. You might go to a restaurant and maybe I like pasta sauces. And the exploit strategy would be, I like really good marinara sauce with fresh tomatoes and basil. And I see that on the menu and it's like my go-to and I eat it. Maybe the explore, maybe a bad explorer would be like something completely out of left field that I have not ever tasted before. It could be like, completely unrelated. What's completely unrelated to pasta sauce? Maybe, I don't know, lobster or something.
Octopus.
Octopus, yeah. And it's like, maybe not. But maybe the waiter's like, a good waiter's like, well, you like a really good marinara sauce and spaghetti. Maybe you'll like, I don't know, maybe you'll like Alfredo. It's a bit of a different step away, but it's still close to what you like. That could be a way to explore strategically, where you sort of calibrate how you're adjusting to the situation. And that's the question, is how do we do this? So we don't want to just like show users random search results necessarily. We don't necessarily want to show them always the same thing. We want to find the sort of like, okay, how can we show them interesting things and use that as a means to gather more information? So our goal is to like have more rows here with a lot more clicks and examines. So what we can do is use a technique called active learning. So what active learning says is, what are the characteristics of what we have information about? We know Doug likes spaghetti sauce, and we can use that to like take a, to figure out what to explore. We know he doesn't like olives. I actually had to think of an accurate example. I don't like olives. I don't like olives, so stay away from olives. But maybe there's what should we show? What should we show Doug? Or what should we bring Doug at the restaurant? What should we show users searching for fashion? And you might think I'm talking about personalization when I talk about me, and this can apply to personalization, but really the only proxy we have in a pure search context is this is the query. So I'm really thinking about just the query for now. So we can learn, we have features, we know things about the documents, each of these rows, and we might know things like the title score is this, like search engines have scores for different fields based on their relevance weighting. Like there's you can go research how that works. But we might know that there are these, for the really relevant ones, there are these strong title matches, and for the irrelevant ones, there are these weak title matches. But we don't have examples where the body score varies much. So what happens if we show the user something where the title score is good and the body score is good? Will that get even more clicks? Or will, for some reason, it won't? Maybe there's something that we don't know there. And conversely, so that's like, giving Doug a slightly different pasta sauce, or maybe a slightly different noodle or something. Conversely, like Doug doesn't like olives, like we reliably know that. What happens if we give Doug a pasta sauce with olives? What happens if we like poor title score and, but maybe the body score is high? Like maybe it turns out that I actually like, a good olive-based pasta sauce if you just don't tell me it has olives in it. We can explore these spaces strategically. And how we do that, one way of doing that is using what's called a Gaussian process and using what's called Bayesian optimization. So we can know in our feature space where the clicks have occurred. The observations themselves can have confidence levels. And you could think that, we just learned that from our beta distribution. We saw the probability distribution of the things with clicks, right? So the observations themselves can have certainty levels. And we have this is not at all related to the data table you saw before, it's something generated. You have these spots here where we have less certainty, like over here, we have a wider way of uncertainty, super high title matches, maybe this one area and so on. And so we can use this as a means to say, okay, how should we explore this space? And maybe our exploit strategy would stay here, but our explore strategy would come over here. And I actually drew this in Google Slides. That's why it looks wonky. But you can see maybe like for the body dimension, we have all these observations here with basically very low body score. But maybe we want to explore over here where the body score is really high. And of course, this is going to be multidimensional. So it's going to also not just depend on one feature. It's going to be like, oh, if the body score is weak, but the title's high, and those kinds of things. And that's going to help us figure out where to explore. So like I said, everything gets down to one line of scikit-learn where you do like a dot fit or something, right? And finally, we're there, but we're actually still preparing training data, hilariously enough. And we can do is fit a Gaussian process using, sorry, I should say a Gaussian process. I never actually defined that. But a Gaussian process is basically a function where each point here has a probability distribution. So each thing has an uncertainty level. And if by the training points, by the points that it's actually trained on, it has lower uncertainty, but away from those points, it has much higher uncertainty. And it tries to basically draw a squiggly line between those points and then say like, well, I drew a squiggly line here, but I'm really uncertain about that. So that's what a Gaussian process is. And each of these points is something from our training data. So we built a Gaussian process, and we can use this to learn where to explore. And this code, I just snippeted it from AI-powered search. But basically, you can think here, we have these features, category and title features. This is like the number of title terms that match and like the category this match belonged in. The Gaussian process, that squiggly line, will make a prediction of the grade. And of course, that prediction in the Gaussian process will have a standard deviation. There's an opportunity if we predict a higher grade than what's actually known, then maybe showing that to the user will give, it will increase the clicks or whatever on that thing. So that's what the opportunity is. And of course, if we don't have any data, the grade's going to be 0, so the opportunity will be very high. And the probability of improvement is just taking that and taking into consideration the standard deviation. So if there's a high opportunity and a low standard deviation, it feels like a safe bet. It feels like, oh, this spaghetti sauce is only slightly different, and it still uses tomatoes, so Doug will like it. It's very similar to what the user has seen in the past for this query. But if there's a wide standard deviation, oh, there's olives in this pasta sauce, I don't know, then that, you're dividing, you can see the math here by a much higher standard deviation. And so it's going to not be a place you necessarily want to explore. And we sort this based on probability of improvement. And there are other ways of scoring. This is kind of the easiest to explain, but there are other ways of scoring this for Bayesian optimization. And we sort this, we say, this might be the best place to explore. A category 4 and title 0. So we can use this to inform, like, when there are times we're going to go out to a ranking process or search engine and just rank results. And we can use this to inform which, maybe we reserve that third result for trying something new, or we shuffle in sort of kind of these unknown items into the results based whatever strategy we want to do in our UX. So that's one strategy for overcoming presentation bias. So with all of this put together, of course, we want to ignore any qualitative feedback, and we want to just go based on clicks, right? But you, after learning all this stuff and putting it all together, you might be like this, your mind is blown. And now we're back here, right? We have, we're looking now at click data, and we're, instead of looking at our, our product manager that we saw from before and saying like, is this actually representative user data? Now we're looking at maybe this complicated process might have bugs, dare I say, and even might not actually work. We might even put this into an A/B test. It doesn't work for whatever reason. So if we're being data driven, we should 100% completely trust this data and ignore anything anyone ever says, right? Well, not quite. I think that I don't necessarily believe in being data driven, because that means you're like a slave to the data. You're like doing what the data says and ignoring everything else. I think we're data users and we're skeptics. So we're always skeptical a little bit of our data. I think it's healthy to have like, all faith is, I don't know, I'm going to make up a saying that like faith is well tempered by doubt, as they say, that you need to have questions about this. And so when someone comes to you with an example that seems off, it is a good time. It's a prompt to say like, oh, that is weird. Let me look at my data. And maybe this person is right and something's wrong in the data. Or maybe we don't have enough data in our clickstream. Maybe we have a bug. Or we can go back to this person and say, well, it looks like users are maybe disagreeing with you, and let's have a conversation about that. And maybe there's a business requirement that's not going to be captured in how users behave that you just have to fulfill. So qualitative feedback is still extremely valuable. And there are going to be many signals that you need to consider. So I talk primarily about processing clicks. And then there's the qualitative feedback from your stakeholders that are really, thoughtful, and usually someone can write like a bug report for you and give you some thoughtful input. I didn't talk at all about like actually robustly going and maybe crowdsourcing manual labels from people. That's like getting explicit labels from people. There are lots of companies. There's one company called Superhands that does this, that goes out and they specialize in like search labeling through crowdsourcing. But search teams really, we need to be skeptics of all of these sources because we need to use them, right? So we're going to obsess over whether or not this data reflects reality when we go to actually do the tuning. And of course, one thing I want to mention is we did all this smart, fancy data science. And of course, speed and UI don't matter, right? We can build the fanciest thing, but one thing I want to mention is even if you get all this right and you deploy your A/B test, it could still fail. And it might fail because the UI is terrible or it takes 5 seconds for search results to come back. And I've been hired as the relevance person on many teams, and given that like this bubble over here, and it's just, there's no point in working on relevance because it takes 5 seconds for results to come back and the experience is terrible. You could easily hit ceilings with those as well. So that's just a little PS. And this diagram comes from a blog post at my last company from a colleague, Max Irwin, that I definitely recommend you check out. So that's it. Questions? We're growing, of course. My LinkedIn is in here. Please feel free to DM me or on LinkedIn or through the Slack. I'm on the Slack. My colleagues are hanging out there. So please feel free to DM me and let me know if you want to try to help make search better for everyone at Shopify. So with that, I'll take any questions.
Yeah, thanks. I don't know if you posted this link to our jobs channel, but if you haven't, you should.
I did a while back, but we will definitely repost it.
Yeah, I just want to remind everyone that if you want to ask a question, there is a pinned link in the live chat. Just click on this and ask a question. And what I wanted to ask you is maybe if you can go through again all the reasons our search project could fail. I remember position bias. I remember this presentation bias. I remember that maybe you incorrectly gather data just relying on one person. What are the other reasons a project can fail?
Yeah, so and this is purely in the realm of processing click feedback for the most part, or getting feedback. But there's, I can go all the way, well, I don't know if I'll go all the way back there, but there's basically not even trying because you're scared to change anything. So and that kind of comes in two flavors. There's operational, like you just can't change your indexing strategy. You can't, and then there's I don't have any data to tune search. So I'm scared to change it because I'll break it. Then there's, when you actually get to click-through data, there's ignoring position bias, and just taking like click-through rate. That usually creates problems. Then there's ignoring the confidence you have in that data. Then there's the presentation bias, where you're just like keeping searches in a bubble. And then there's ignoring qualitative feedback after all that, because we still need to take that to make sure that how we're understanding data is correct. And finally, yeah, you can still do all that in your speed, and in UI can be the limiting factor.
Yeah, thanks for the summary. And in your experience, what is the most common cause for a failure?
Oh, the most common, well, actually, I will say probably the most common cause for failure is not thinking that deeply about this stuff, and not being sufficiently data informed, but also data skeptical. And not, the really good search teams I've seen invest I like to make this statistic up because it shocks people maybe, but spend like more than 50% of their resources on instrumentation and measurement. And the ineffective search teams maybe get a little too obsessed with fancy algorithms before they have confidence in their training data. So that's probably what I would say.
Mm-hmm. Yeah, thank you. And we have actually a related question, I think, related to instrumentation. And so, how to validate that our results and ranking are good enough?
Yeah, usually the way you do that, I mean, there's no what is relevant, what is objectively true, right? The way that I like to think about it is you have these different perspectives on the problem. You have your implicit data from users. You have maybe what an A/B test says, maybe what explicit raters are saying, what your feedback internally is saying, and they're all valid points of view. Like there's no like one perfect metric in for anything, right? And you tend to see like what's interesting is where there's agreement, you're probably okay. You feel pretty good about things. You feel like things are moving forward. When there's disagreement, that's really where you can get a lot of insight of why that is the case. Like why do click workers do something different than our users? And that's where you gain insight and confidence in this kind of data is going to be useful for knowing, maybe just labeling things as relevant or not. Oh, did we lose Alexi? Hey.
You did lose me. Hi. That's the
Hey.
first time it happens on a stream. I am actually, well, hopefully it's still live. I see.
Yeah.
My computer just decided to die.
Cool. Yeah, so when you see these places where things disagree, that's where it gets really interesting, because you look at different reasons. And also, like at Shopify, we have like so many storefronts, and people do slightly different things in all these storefronts, and you can see like variations of behavior on implicit behaviors too. And so you could see just so much diversity in how people behave and how people interpret and rate search results. When you see the differences and why they're disagreeing, that can give you insight of where it's valuable and where you don't want to use it, and how that contributes to the overall solution, if that makes sense. Because the disagreement can give you like so much insight, like this might seem to be irrelevant to the average person, but in this specific case, for the people who actually search for this, they actually do want this specific thing because they're part of this weird, specific internet community, and they're shopping for something.
I don't remember what you were answering. Yeah, thanks for the answer.
Sure, yeah.
So I remember, before my computer died, I remember seeing other question. It was about the Gaussian processes. And the question was, I don't remember how exactly it was phrased, but it was about like in click data, we typically have these long tail distributions, like items that are not clicked on that often. So how does this Gaussian regression deal with this sort of long tail distributions?
Yeah, that's a really good question. So out of the box, the Gaussian process assumes that when you give it a data point, it has no uncertainty. Like that is the data point. So if you think, like we talked about confidence before, one click out of one examine, you assume that's a 1.0 and you have no doubt that that's a 1.0 grade, right? Even if we beta adjusted that and we said, okay, really that's a 0.2, let's say, when we give that to the Gaussian process, it just sees that as a known thing with no variance. We can, however, if you do a little bit of work with scikit-learn, you can say my data point actually has this variance. It has this amount of uncertainty in it. So you can say this is like a 0.2 with a pretty wide distribution. And that's kind of why I showed all the way back here even though like in a normal situation, the gray area actually collapses to the blue line. But I'm trying to reflect the fact that we actually, this red bar, we have this point, but this red bar that's kind of a uncertainty, and different points might have, this point here has a higher uncertainty and this one might have a lower uncertainty. Maybe we have much more confidence. So maybe we've used our beta distribution and derived some kind of variance. It's a bit complicated because this assumes that like this is a Gaussian distribution. So you kind of have to like play games with it a little bit, but that's how you can do that.
Thank you. Do you have time to take a few more questions?
Yeah, definitely.
My computer is back to life, so I have access to questions. That's good. So in e-commerce, is it also possible to optimize for sales? Is it more? It's not a question. It's like sorry, it's a statement. In e-commerce, it's possible to optimize for sales. Is it more favorable than optimizing for clicks? Is it also subject to position bias?
It will be subject to position bias. I think that's a really good question. And one thing that I think about a lot that I didn't actually talk about in this, but I talk about it in AI-powered search is, in this, I talked about sort of the data-ish problems, position bias, confidence, and presentation. But there is another bias that I call attractiveness bias. An attractiveness bias is when something gets clicked on but doesn't result in the expected follow-on conversions, or the opposite, where something is maybe undersold. It's not clicked on, but in other contexts, it sells really well. So that's, you could get a disconnect between clicks and sales in that way. And sometimes things can be spammy or malicious, or they show an image that isn't true or overpromises. And they clicked a lot, but then it doesn't actually turn out to actually result in whatever conversion. And to me, yes, you can use sales, but there's a couple of things going on. Sales data is going to be sparser than click data. So click data is going to be higher abundance. And the other thing is, I kind of like to know when there's a disconnect between those two. So if a product page sells well in other channels, but doesn't sell well in search, does that mean that it is there is a problem, like I talked about before with the UI, where the UI is not highlighting, the UI / the content, I should say, is not highlighting what's really unique about this product? Does it, maybe it's missing an image, or the image is really bad, or the title is really bad? And therefore, it's really that kind of problem. It's a problem in like how it's presented, and how it's explained to the user why it's relevant for their result. And the other thing too, like if something just seems to be clicked on all the time, but no one sells it, do I need to look at that to see if there's spam, if it's malicious, or maybe just the product page is terrible in general? Maybe in other channels, it also has that issue. So that's how I tend to think about it. I tend to think about it as like a way to look for the disconnects between those things, and maybe triage where there might be problems.
Thank you. Maybe the last one today. Actually, we have quite a lot of questions, but maybe let's pick the last one. And so what we usually do in this case when we have a lot of questions, there is a channel in our Slack called Events Q&A, and I just post the questions there. And if you do have time after the event, just answer. And if you want to get your answer to your question, you can go to our Slack and find it later. Okay. So the last question for today is, what kind of data quality checks do you perform while processing the data?
Oh yeah, what kind of? That's really good. So we have issues with bots. We have issues with, Shopify has apps. We have issues with people using search to drive their apps or to look up products, and it's really hard to like 100% filter it all out. The best we've been able to do is, we do have some bot detection, and I don't know how much I want to get into this because I don't know if people are, developers might try to circumvent it. We do some bot detection. We have some patterns that we look for that seem to be clearly someone understands that this is a search engine and they're searching structurally for something like a list of SKUs or something like that. So we tend to look for those kinds of patterns and filter them out. But yeah, we also have just times where we lose data, where we track this, and Shopify has a pretty robust, because some of this data that we talk about is our merchants want to use it too. They want to see how people are searching and shopping. So it's not just internally for us, it's also a product sometimes for merchants to give them insight. So we do treat these issues for our company pretty importantly, and like any kind of other outage, it's like an issue that needs to get resolved and dealt with quickly. So I don't know if that answers the question, but yeah, it's a constant. I mean, I think it's a constant battle, and it's a constant battle everywhere. For the Shop app specifically, the good thing about that is, you actually have to download an app. The Shop app, for those who haven't used it, is used to track deliveries of all kinds of things from all kinds of e-commerce shops. So there is a level of like, is this a real user going on there, that helps us with that problem specifically.
Yeah, thank you. And for the rest of the questions, I will post them in the events Q&A channel in our Slack. And I will also make an announcement in general. So those who are watching, you can go to our Slack and then find the answers there. Thanks a lot for your presentation. It was quite interesting. A lot of new things for me also. And yeah, thanks a lot.
Thank you, everyone. Have a good rest of your day.
Yes, thanks everyone for joining and for asking questions. And yeah, have a great day. Goodbye.
Take care.